Tethys, one of Saturn's largest moons, measuring 10,060 kilometers in diameter and orbiting approximately 295,000 kilometers from Saturn, has become a focal point of scientific attention since the Cassini-Huygens mission uncovered the hidden mysteries on its surface. With its unique geological features, Tethys has left scientists in awe and wonder. One of the most remarkable discoveries was Ithaca Chasma, a massive 2,000-kilometer-long fracture that encircles almost the entire surface of Tethys. This indicates that the moon may have once harbored an underground ocean or semi-liquid water beneath its surface. Moreover, the Odysseus impact crater, with a diameter of 450 kilometers, 40% larger than the moon's own diameter, suggests an immense collision force, powerful enough to have potentially shattered the moon if it had been solid throughout. Could it be the moon's soft internal structure, almost entirely devoid of a metal core, that Cassini uncovered? Furthermore, the discovery of the Pac-Man phenomenon, an unusual thermal region where ice behaves in unexpected ways, has revealed the complex interactions between Tethys and Saturn's environment. These findings not only illuminate the geological history of Tethys, but also raise new questions. What other secrets remain hidden on the surface of Tethys, waiting to be uncovered? From the first images, Tethys appears to be a cold, strange world. But to truly understand why it has endured for billions of years, scientists had to look beyond its icy white shell, where an extraordinary structure lies, one that challenges our traditional understanding of planetary geology. According to gravitational data gathered by the Cassini spacecraft during its flybys of Tethys from 2005 to 2017, the average density of this moon is only about 0.97 grams per cubic centimeter, nearly the same as liquid water. This startling figure left researchers astounded, as no other medium-sized celestial body in the Saturn system is this light. For comparison, Earth's moon has a density of 3.34 grams per cubic centimeter. This suggests that Tethys is almost entirely composed of pure water ice, with only a tiny amount of rock or metal. But Cassini uncovered something even stranger. Tethys has an internal porosity of nearly 20%. Meaning that this icy sphere is like a giant sponge. It isn't a solid block of ice, but rather a loosely structured world with countless voids, as if its interior was once bubbling with activity before slowly deflating over time. Could Tethys have once had underground flows within its ice? Much like Enceladus today ejects water vapor from cracks near its south pole. If that's true, then Tethys isn't a dead moon as we once thought. Instead, it could be a world that has fallen into slumber, carrying within it icy seismic activity from billions of years ago. Because of this porous structure, Tethys doesn't respond to impacts like rocky celestial bodies. When struck, instead of shattering, its soft ice absorbs the energy, deforming the surface and then gradually flowing back into balance. The ice on Tethys isn't completely solid. It exhibits what is known as viscous deformation, meaning it can slowly stretch and compress under the effects of gravity and extreme low temperatures. This mechanism explains why the Odysseus crater, the massive scar observed by Cassini, gradually flattens over time. So, could it be that beneath this still ice shell, some energy remains, enough to cause Tethys to move slowly in silence? While Cassini showed us only part of the surface, it is the soft, hollow, and quietly deforming internal structure that holds the key to unlocking Tethys's survival story. A world that doesn't need lava or raging winds to change. Perhaps this is why, even though it seems tranquil, Tethys still hides subtle movements beneath its white, icy shell, as if the entire world is quietly breathing in the cold void of Saturn. So, what lies hidden beneath those massive scars on its surface? Let's dive into the mystery of Ithaca Chasma, a crack so long it could split an entire moon in half. Before we continue this journey, if you're enjoying the exploration, hit subscribe on WUFO right now so you won't miss our next discoveries. When Cassini captured images of the surface of Tethys, scientists were stunned by the size of Ithaca Chasma. This is a massive crack stretching 2,000 kilometers long, about 5 kilometers deep, and up to 100 kilometers wide. Even more astonishing, it covers nearly 3/4 of the moon's circumference. If placed on Earth, it would be a crack stretching from New York to Denver, an incomprehensible scale for a small moon like Tethys. Geometric images from Cassini show that Ithaca Chasma is not isolated. It consists of many parallel and overlapping stretching rifts, steep cliffs, and relatively flat valley floors, typical of an extension tectonic process in brittle ice. How could a moon just over 1,000 kilometers in diameter withstand such a massive rift structure without being torn apart? The first theories were built around a collision scenario. Scientists once thought that Ithaca Chasma could be a rift from the rebound of the impact that created the Odysseus crater, a massive crater located on the opposite hemisphere. However, the geometry of the crack didn't match. If it were from a collision, the fracture lines would spread in a fan shape, not as a long, straight, concentric crack, but the depth analysis and mechanical models published in 2018 completely dismissed this theory. Ithaca Chasma, it turns out, was born from within, not from external violence. This opens up another possibility, and one of the most significant discoveries Cassini has provided. Ithaca Chasma may be the direct consequence of the planetary freezing process. Imagine a frozen world that once hid an underground ocean. In its early days, Tethys orbited Saturn at a closer distance than it does today. The immense gravitational pull of its parent planet caused powerful tidal forces, causing Tethys's core to bend, heat up, and partially melt. Underneath its thick, icy crust, there may have been a shallow, semi-liquid water sea, enough to alter the thermal balance in the entire moon structure. But tidal energy doesn't last forever. As Tethys's orbit gradually stabilized, internal friction decreased, and the underground ocean began to freeze. That's when tragedy struck. As the water transitioned from liquid to solid, its volume expanded by about 9%. In a body estimated to be 99% made of ice, this expansion was a planetary-scale earthquake. The pressure generated from within caused the outer crust, already cold and brittle, to stretch, crack, and break apart. According to a 2020 study by JPL NASA, this overall expansion could have caused Tethys's radius to increase by about 5% during the freezing process, equivalent to tens of millions of tons of ice being pushed outward. In Ithaca Chasma is the massive rift that marks the moment Tethys transitioned from a world with an underground ocean to a frozen, dormant ice world. Cassini captured 3D elevation images of this region, showing the rift edges being bent and subsiding, evidence of slow but continuous stretching, not caused by a single event. A 2021 report from Geophysical Research Letters also indicated that the topographic traces around Ithaca Chasma matched the phenomenon of flexural bending, the elastic bending of the ice crust under long-term tensile stress. This means that Ithaca Chasma is not just the result of a single event. It is the remnant of an entire series of thermal and mechanical transformations throughout Tethys's history. What intrigues scientists the most is whether that freezing process truly stopped completely. Infrared spectral data from Cassini show slight variations in crystal ice composition along the edge of Ithaca, possibly signs of weak thermal flows, places where ice once melted locally and recrystallized. Though these are just the remnants of a geothermal cycle that has been dormant for billions of years. This is why Ithaca Chasma has become a prime target in planetary ice evolution simulations. Researchers from Cornell University and JPL are using thermodynamic models to recreate Tethys's cooling history. They found that if Tethys's outer crust was less than 40 kilometers thick, the freezing process could still be occurring just beneath the surface. In our solar system, where most moons are just cold, lifeless rocks, Tethys stands out as a world that once moved, once changed volume, and now remains frozen in that transitional state. And each time Cassini flies by, its close-up images of Ithaca Chasma raise yet another question about it. But one thing is clear. This rift is not just topography. It is the fossilized journal of a planetary death throe, evidence that even in the coldest vacuum of space, ice worlds can still stretch, breathe, and change, even if only in slow, nearly imperceptible beats, lasting longer than the lifespan of human civilization itself. Throughout Cassini's exploration journey, one image has captivated the scientific community: a gigantic scar etched into the icy surface of Tethys. This massive crater is known as Odysseus, not just a crater, but the remnant of an ancient battle between matter and energy, between destruction and survival. From afar, with a diameter of 450 kilometers, it covers 40% of the Moon's total diameter, making Tethys look as if it had been torn apart nearly halfway. To put it in perspective, if this crater were on Earth, it would stretch from Los Angeles to Salt Lake City. But what really astonished scientists wasn't the size of the impact, but the question: how could a world almost entirely made of ice survive an impact with the force of 1,000,000 hydrogen bombs. According to gravitational data collected by Cassini, the impact occurred somewhere between 400 million and 1 billion years ago, during a time when Tethys was cooling down and its internal structure had yet to fully solidify. The energy from the impact was enough to tear apart a solid celestial body into thousands of pieces, yet Tethys stood resilient. The answer lies deep beneath its icy surface. Geophysical data indicates that Tethys is not made of solid ice entirely. It has a semi-liquid core consisting of soft ice, solid matter, and supercooled water. This core acts as a giant cushion, absorbing and dissipating the energy from the impact, preventing the moon from shattering. While rocky moons like our Earth's moon would have exploded under such an impact, Tethys deformed, bent, and then returned to its original shape, a strange reaction of ice under immense pressure. But the wonder doesn't stop there. When Cassini scanned the Odysseus region with infrared imaging and radar altimetry instruments, scientists discovered something incredible. The enormous impact crater had been flattened. Normally, such a deep crater would retain its edges and a sunken floor. Yet here, the crater's rim had collapsed, the floor had risen, and the surrounding surface was noticeably brighter. So, what exactly happened? Geological models suggest a phenomenon known as viscous relaxation, where ice, although solid, can still flow extremely slowly under the influence of gravity and pressure over millions of years. Unlike the ice on Earth, Tethys's ice has a high degree of plasticity due to its extremely low temperatures and special crystalline structure. Like a super viscous fluid, it moves gradually, flattening the massive impact crater. Cassini's spectroscopic measurements also revealed another mystery. The ice surrounding the Odysseus crater reflected more light than other regions. This indicates the presence of recrystallized ice, where the ice cracked, locally melted due to the impact's force, and then refroze, creating younger, cleaner layers of ice. Essentially, Odysseus is not merely an ancient scar. This revelation has caused scientists to rethink the old view of frozen dead worlds. A 2023 study by Cornell University demonstrated that viscous relaxation process on Tethys could still be happening right now, at a rate of only a few millimeters per century. The Odysseus crater is still subtly changing, the ice is still moving, shifting and reforming in silence. Could it be that ice moons like Tethys, Enceladus, or Europa are not just remnants of the past but are active physical ecosystems where ice, rather than fire, drives planetary evolution? While Earth renews itself through volcanoes and storms, Tethys recovers through silence and time. No volcanoes, no atmosphere, no oceans, just ice flowing very slowly, and gravity slowly reshaping it. Many researchers at the Planetary Science Institute believe that this very characteristic is what makes Tethys a symbol of resilience in the universe. in a world where most celestial bodies are destroyed or disintegrate after an impact. Tethys still endures. Could it be that, in the absolute silence of space, and perhaps in that very silence, it's sending us a message? That even in the cold and darkness, life, in some form, never stops finding ways to survive? After the discovery of global cracks and massive craters like Odysseus. The temperature on Tethys has also left the scientific community perplexed. A cold moon with no atmosphere, no volcanoes, and no oceans, yet it reveals an unusual thermal signature. Not an optical phenomenon or light effect, but an actual temperature map recorded by Cassini's VIMS visible and infrared mapping spectrometer. In this map, a Pac-Man shaped cold region stands out against the warmer dark background of the rest of the surface. When analyzing the data, scientists noticed a paradox. The leading hemisphere of Tethys, the part always facing forward as it orbits Saturn, is noticeably colder during the day but warmer at night, compared to the opposite side. At first, many scientists thought that the temperature differences could be due to brightness, color, or terrain. However, these hypotheses were quickly ruled out. Measurements showed that this difference was not related to color or light reflection, but stemmed from a deeper physical phenomenon. Thermal inertia, the ability of materials to retain and release heat over time. Cassini's data shows that the leading hemisphere of Tethys is covered by ultrafine, extremely pure ice particles. These particles originate from a thin ice ring of Saturn. Nurtured by water plumes from the Moon Enceladus, as Tethys orbits its parent planet. Its leading surface is continuously bombarded by this ice particle rain. As a result, a porous, bright layer forms that reflects light at an astonishingly high rate. Cassini measured this area reflecting nearly 80% of the sunlight. (15 to 20% higher than the surrounding areas. However, this dazzling brightness makes it hard for this region to absorb heat. And when any heat does manage to penetrate, it dissipates almost immediately. In contrast, the trailing hemisphere of Tethys tells a completely different story. It is not covered by pristine, clean ice, but is constantly bombarded by high-energy plasma from Saturn's magnetosphere. Along with countless micrometeoroid impacts. These forces darken the surface while compressing the ice's crystalline structure. The ice here becomes denser, smoother, and thicker. A material with high thermal inertia, meaning it retains heat for much longer. When sunlight strikes, the trailing hemisphere absorbs more heat, and when night falls, it slowly releases that heat. Maintaining a higher temperature than the Pac-Man region. Contrast between the two hemispheres, one bright and cold, the other dark and warm. Creates a clear Pac-Man-shaped thermal map, something no scientist could have imagined before. But what's even more intriguing is that this Pac-Man shape isn't static. When Cassini revisited Tethys in 2015, this region had expanded and changed shape. This proves that Tethys's surface is not static but is continuously reshaped by its surroundings. Researchers believe this is a direct signature of planetary satellite interaction. Saturn, with its massive magnetic field and complex icy dust system, is leaving its mark on each ice grain on Tethys. This raises a question for scientists. Could other giant planets in the solar system have moons whose surfaces are dynamically shifting in a similar manner? A 2022 study published in Geophysical Research Letters confirmed that the Pac-Man phenomenon is not only present on Tethys, but also appears on Mimas and Dione, two other moons of Saturn. This shows that it's not an isolated phenomenon, but a systemic thermal characteristic across the entire Saturnian system. If this is the case, Tethys could be considered a living thermal map, recording every change in Saturn's activity. From plasma intensity to dust density and Enceladus's eruption cycles. Each time the thin ice layer on Tethys is refreshed, its temperature changes, and the Pac-Man shape deforms accordingly. But the biggest question is whether this phenomenon is just a physical interaction or if it signifies a more complex energy process taking place within. Some recent models conducted by NASA's Jet Propulsion Laboratory suggest that these unusual thermal fluctuations might affect the reorganization of ice crystals to a depth of several meters, impacting the surface's strength and reflective properties. In other words, Pac-Man isn't just a surface image, but is also altering the physics beneath Tethys. This marks the first time in astronomical history that humans have recorded a global thermodynamic signature between a planet and its moon. And Tethys has become a testament to that delicate interaction. Cassini-Huygens mission, with its groundbreaking discoveries, has transformed the way we perceive Tethys and other icy moons. As well as how we understand the interactions between celestial bodies in our solar system. If a world as simple as Tethys once harbored liquid water beneath its surface, then the possibility of subsurface oceans existing on other moons like Europa or Enceladus becomes far more plausible. In this way, Tethys serves as a model for studying the origins and limits of life in extreme cold conditions. Tethys' journey reveals that even in the harshest conditions, a world can survive and preserve traces of its past. In the vast context of the cosmos, Tethys' story raises profound questions about life, evolution, and the connections between worlds. Tethys is not a forgotten moon. It reminds us that in the universe, no world is truly silent. Even in the absolute cold, stories are written in ice, light, and time. And it is this silence, resilient, steadfast, and ever-changing, that serves as a reminder that every planet has a history. And every scar is proof of survival. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.